Okay, so we have a list of numbers and the value k, and we want to remove some numbers like this to make minimum not less than maximum times k. So for example, we have numbers 1, 1, 1, 10, 10, and k equal 2. So the minimum is 1, maximum is 10, and minimum times k should be no less than, so it's like this. So we can remove either 3 ones or 2 tens because they are not matched together. So first of all, we have to sort. The second of all is invert the problem, and instead of finding the minimum removals, we have to find maximum window, and this window is sorted like this. Just sorted, and then we can check the first value and the last value, and first should be first times k, and 5 compared to 5. Now let's look at my solution. I wrote it like this. So invert the problem, and the maximum window and minimum removals is the size minus maximum. And this is 2 pointers. I use the left pointer to slide the left side and always increment the right pointer. Now the second corner case is that integer overflows, so we have to convert them to longs. Now this solution is kind of simple, and actually if you look at other solutions, they are pretty much clever. So let's look at a clever solution. So the clever solution is this one, but I will unpack this first, like this. So instead of finding the maximum window and shrinking it, we use this technique called a lazy window. Lazy window, and we have j and I, and this part is almost the same as it was before, but suddenly we using, instead of while, we're using if, and instead of finding the maximum of I minus j plus 1, we using this just maximum of j. And as you can see, we don't use an n minus. So this is kind of inversion of the sliding window, because this is not actually, it is mean removal, but we found it in the maximum. So the maximum is kind of irrelevant, because we're just moving the window. You can see it in Rust. So it is just a window, and we increasing it each time the value is bigger out of bounds. So this is how it looks like. It's actually not my solution, it is from this genius guy Lee, and he didn't explain the logic. It's kind of sliding window, move the left pointer, otherwise we can expand the size of the window. Okay, if we look at this, like 1, 10, 10, 50, and k is 2, our j is at 1, I is at 10, we compare, it doesn't match, so we move j. And that means if the array would stop here, that would mean that we are removed 1, because j equal 1, so we removed one of these two elements. Now we're going to next I, and compare them together, and they are okay. So we don't increment, so the answer is the same. And when we move I to the 50, we again look at j is 10, then and 50 doesn't match, so we incrementing the j equal 2, and this is the answer of how many we should remove. So we have removed before 1, like this. Now we removed 2 values, and if we want to know exactly what kind of values we remove, we would remove first and last, but this solution doesn't care about exact positions. It just counts, it's a counter how many values doesn't match a window. So the window, actual window, is size minus j. This is a window. A solution is just a golf, and when we shrink or expand, oh no, shrink, we are shrinking the window, shrink, we increment in j. So this is kind of how it works. Honestly, I don't actually have it in my fast brain. Okay, that's it for today.